Good morning, everybody. Today we are discussing the next topic, that is the nuclear fission reaction. In the last class, we are discussed the nuclear fusion reaction. Now we are discussing the next topic, that is the nuclear fission reaction. The fusion reaction. So nuclear fusion reaction means it is a process in which two lighter nuclei fuse together and to form a heavier nuclei with the simultaneous release of the huge amount of the energy. This process is known as nuclear fusion reaction. See here I have quoted one example. The deuterium and tritium both are the isotope of the hydrogen fuse together and we will get helium and one neutron, and tremendous amount of the energy is released during this process. And this energy, we can calculate the amount of the energy by using Einstein equation E is equal to mc square, where m is the mass defect and c is the velocity of the light. Now we are moving into the sum of the example. See here, the nuclear fission reaction, fusion reaction generally is the combination of the lighter nuclear, say for example the hydrogen, and to form the helium nucleus, that is which is heavier than that of the parent hydrogen nucleus, and the tremendous amount of the energy released. This is basically nuclear fusion reaction. Now we are moving into the sum of the example. The deuterium combined with deuterium and to form the helium nucleus, and 25 million electron volt of energy is released. Next example, tritium combined with the protium and to form the helium, and 20 million electron volt is released. Similarly, the deuterium combined with the tritium and we will get helium and neutron, and 17.8 million electron volt of energy is released in this reaction. Now we are moving into the some of the general characteristics of the nuclear fusion reaction. First is, the nuclear fusion reaction is generally taking place at very high temperature of the order of million degree Celsius. So this is because in order to avoid the nuclear repulsion between the parent nuclei, we have to create the high kinetic energy for the parent nuclei. This is occurred by giving them the high temperature. So since the reaction occurs at very high temperature, the nuclear fusion reactions are commonly known as thermonuclear reaction. And this nuclear fusion reaction is very common in stars, and the hydrogen bomb is based upon the nuclear fusion reaction. Yesterday we have studied the atom bomb. Atom bomb based upon the principle of nuclear fission reaction, and hydrogen bomb is based upon the principle of nuclear fusion reaction. And since I have already mentioned that the nuclear fusion reaction occurs at very high temperature, that's why first of all the reaction, the hydrogen bomb is initiated by the fusion bomb or atom bomb in order to generate the high temperature. Now we are going to the next important topic, that is the difference between nuclear fission and nuclear fusion reaction. It is very important, frequently asked university question. First one, nuclear fission reaction is the definition itself, that is heavy nuclei split up into subatomic into two fragment of lighter nuclei due to the bombardment with subatomic particle. Whereas nuclear fusion reaction is the combination of the two lighter nuclei and to form the heavier nuclei. The next difference is, the nuclear fission reaction is a very spontaneous reaction at ordinary temperature, but nuclear fusion reaction occurs at very high temperature. And the third difference is, mass of the product of the nuclei are lower than that of the parent nuclei in fission reaction, whereas in the fusion reaction, lighter nuclei fuse together and to form the heavier nuclei. And the last difference is, nuclear fission energy is released per unit mass is large, whereas in the nuclear fusion reaction, this amount of the energy released per unit mass is even higher than that of nuclear fission reaction. So these are the difference. It is very important. Nuclear fusion reaction, definition of the nuclear fission and fusion reaction and the example is also very important. Thank you.